Hello, my dear students. I am Mukesh Tilwani, Assistant Professor in MLV Textile and Engineering College, Bhilwara. Today, I am going to discuss about the numericals on the extrusion and wire drawing operations. Uh, this is the subject of the manufacturing processes. In last lecture, I had discussed about the analysis of extrusion and wire drawing operation. With uh, with the help of analysis, we solve the numerical in today's lecture. First numerical is a brass billet is to be extruded from the initial diameter 100 mm to final diameter 50 mm. The working temperature is 700 degrees Celsius. This is the hot working. This is the hot working because the brass because here we give the temperature above the recrystallization temperature. Therefore, the extrusion is of a hot extrusion process. Extrusion constant is 250 megapascal. Then calculate the force required. The formula used for this numerical is this: force is equal to initial area into K ln AI upon AO. Here, the question in the question the given the diameter, initial diameter and final diameter is given. With the help of initial diameter and final diameter, we calculate the initial area and final area. Area is equal to, here the area is equal to pi by 4 into diameter ka square. So we calculate the area AI and AO with the help of initial diameter and final diameter. Then the relation will be pi by 4 into initial diameter 100 square into extrusion constant 250, which is in megapascal. We can say the Newton per mm square. So we don't have to change the unit here, and ln AI upon AO. Pi by 4 is cancelled out here. So the here the ln will be ln of 100 square divided by 50 square. If we solve this, we get the result 2.72 mega Newton. Next numerical, using direct extrusion process. It is a type of extrusion process. A round billet 100 mm length and 50 mm diameter. 100 mm length and 50 mm diameter is extruded. Considering the ideal deformation condition, which is no friction and no redundant work. Here the extrusion ratio is given, which is the initial area upon final area, and the average flow stress is given 300 megapascal. Then calculate the pressure in megapascal on the ram will be. The pressure here, the pressure will be the force upon initial area. So first we have to calculate the extrusion ratio. The extrusion ratio here given is 4. So AI upon AO will be 4. Then for calculating the pressure which is the sigma P, which is equal to sigma naught ln AI upon AO. So sigma naught is given 300 ln. We change the diameter into area with the help of pi by 4 into d square. So AI will be 50 square. Sorry, here AI upon AO is given, so no need of changing any values. So AI and AO is given here. we put directly AI upon AO 4. So the result we get 415.89 Newton megapascal. Next numerical, a wire drawing operation. Here now we discuss the wire drawing operation, numerical on wire drawing operation. Diameter of the steel wire is reduced from 10 mm to 8 mm. So the initial diameter is 10 mm and final diameter is 8 mm. The mean flow stress is of the material is 400 megapascal. Then calculate the ideal force required. Here ideal word means ignoring the friction. So we have to calculate the force in wire drawing operation, which is A naught sigma naught ln AI upon AO. First, we have to calculate the area with the help of pi by 4 into d square. Then put the values in this equation. For putting the values in this equation, P is equal to A naught will be pi by 4 into the outer diameter. Outer diameter will be 8 square into sigma naught is given 400 into ln AI upon AO. AI which is we change the AI with the diameter with the help of pi by 4 into d square. So we get 10 square upon 8 square. Pi by 4 in numerator and denominator, pi by 4 is cancelled out, so the ln will be 10 square upon 8 square. Then we get the force 8.97 kilo Newton. Next numerical, the 10 mm diameter annealed steel wire is drawn through a die with the speed of 0.5 meter per second. Here the flow velocity is given in the question, which is 0.5 meter per second. To reduce the diameter by 20%. Here the reduction is given, percentage reduction is given in the question, and the yield stress for the materials is 800 megapascal. We can also say it is the flow stress of the material. Neglecting friction and strain, we have to calculate the stress required in the drawing operation. For calculating the stress in the drawing operation, we use the outer area, force upon outer area. So we have to calculate the outer area here. The drawing stress will be sigma naught ln AI upon AO. Putting the value, sigma naught will be 800. Here first we have to calculate the outer diameter. We have to calculate the outer diameter first. Then we have to proceed. How can we calculate the outer diameter here? The reduction in the diameter is 20% here. So initial diameter is 10, and the outer diameter reduced by 20%. Then we have to multiply it with the 0.8. So we get the 8 mm. The 8 mm will be the outer diameter after the wire drawing operation. So the drawing stress will be sigma naught, which is 800 ln AI which is 10 square upon, this is 10 square upon 8 square. So the drawing stress will be the 357. After calculating this, the drawing stress will be 357 megapascal. this is a linked question with the next question. The next question is linked with this question. So we continue with the numerical here. We can calculate the force with the help of drawing stress. For calculating the force is equal to, in wire drawing operation, force is equal to sigma d into outer area. So the sigma d is calculated as 357 into the area, outer area will be pi by 4 into d square, which is 8 square. So we get the drawing force, which is 17946.269 Newton. The next question is linked with this question. So for calculating the power, we need the force. So here I have calculated the force. Now for continuing the last numerical, we have to calculate the power required for the drawing process. So the power is equal to force into velocity, and velocity is given here, and force we have calculated. With the help of force and velocity, we calculate the power. The force is 17946.269 into velocity given 0.5. So the power will be 8.97 kilowatt. Today I'm going to close this lecture. In next lecture, I will discuss the numericals on in which we use the friction. With friction numerical, we get the numerical from the with the help of the by considering the with friction, we calculate the drawing stress and extrusion stress in next video lecture. Thank you so much. If you have any doubt, you can ask.